So, in this series of our advanced data structures and algorithms, in our previous lecture we have started with list and iterators, abstract data types, and we understood what actually an abstract data type is, and within that flow we have started with vectors, and we understood what is vector. So, with a quick recap of vectors, we will drill down into more ways to deal with vector. So, basically vector, when we talk about it, is actually a dynamic array which is having a ability to resize itself automatically. That means when an element is being inserted or deleted, the storage will be handled automatically by the container. So, vector is implemented in the form of a container, and vector elements are placed in continuous storages as we did in case of arrays, and because of this continuous storage, these vector elements can be accessed and traversed using iterators. So, iterators is something which is used to kind of access and traverse elements which are stored in continuous storages. So, about this iterators we will be kind of talking in further details, but let us see how to kind of implement vectors, or how are we going to deal with vectors. So, there are basically 8 ways to initialize a vector in C++. What are those ways? We will be looking into them one by one in detail, and along with these the explanation detail, we will also be looking into the code snippet which will give us a clear idea of all these 8 ways to initialize the vector in C++. So, the first way is to use initializer list. Second way is one by one initialization. Third is with a single value. Fourth is from an array. Fifth is from another vector. Sixth says from any STL container. Seventh is by using std fill function, and the eighth one is by using std iota function. So, these are the 8 ways to initialize vectors in C++. Let us begin with the first way, which is using initializer list. So, we are going to initialize, or we are going to create a vector by using an initializer list. So, vectors can be initialized using a list of values, and that list of values has to be enclosed inside curly braces separated by commas. Now, the syntax which is going to be used is available here on the screen. So, we can write vector, then within the angle bracket t, as in that for data type, then the vector name is equals to, and the list v1, v2, v3, whatever the number of elements you want within the curly brackets. Another syntax could be, instead of writing or using an equals to which is the initialization operator, we can also pass this list as a parameter inside that vector name, which is the second line of the syntax written on the screen, which says vector t vector name, and within the parenthesis we have passed that v1, v2, v3 list within inside the curly bracket. So, let us see how are we going to use this. So, in order to look into this code snippet, we will be including, first of all we will be including bits or standard C++.h header file, so that at every point of time whenever I am using vector, I need not to qualify that with the std. Then using namespace standard, you are already aware of what is this, but before going into our main function, we have used we have written a print function. This print function, if you can see in detail what is this print function is doing, this print function is actually kind of accessing the elements of the vector by one and printing printing all those elements. So, this is void print v is the name of the function, and within this bracket we have passed vector and that of an integer type, ampersand v, this v is nothing but the name of the vector, and this is passed using this ampersand, and I am sure that you are aware of why we have why it is required to pass this with the help of an ampersand. And within this we have used for integer I is equals to 0, I less than v dot size. Now v dot size is actually a function which is going to determine the number of elements of v. So from starting 0 to v dot size, and this is the way the indexing of the vector is going to take place as the indexing of the array is going to take place, that is from 0 to n minus 1 or the size minus 1. So I less than v dot size I plus plus, and then we have C out v of I, that is the ith element of the vector v, that is to be printed, and then we have ended the function with an ender. So basically we have written a function which is going to take this vector element by element and going to print that. Now coming to, we need to initialize that vector first. So in order to initialize that vector first, we are using the way of initializer list which we are describing presently. So within that main function, first of all we have created an empty vector, and how to create an empty vector, that we have seen in our previous lecture. So vector, and within the bracket the data type, we are going to create a vector of integer data type, and the name of the vector is v1. Now in this v1 we will be passing an we will be passing, or we will be giving an list, and then we will see how it is going to work. Now first of all we have created an empty vector which is in the name of v1, and now we are going to create one more vector of 5 elements, and this is the way in which we are using this initializer list. So vector int name of the another vector which is v2 is equals to, and 5 elements we have given here. Now we have created one empty vector, another vector with 5 elements, and in order to create that next vector we have used the initializer list. Now one idea could be how to create a vector of 5 elements with a default value, that is also a possibility. So we have created another vector which is v3 in the form of vector int v3 5, 9. So 5 is the size, 9 is the default value, and this is also a way of creation. That means by default we are creating a vector, and we are initializing that with a common value for all the elements, and that common value for all the elements is nothing but 9. And now here we are passing all the 3 variables which are v1, v2 and v3 in our print v function one at a time. That means there are 3 calls to this print v function: print v v1, print v v2 and print v v3. So print v v1, first of all this is an empty vector, it is not having anything. v2 is being initialized with the help of initializer list, and the elements are 1, 4, 2, 3, 5, and the third vector which is being created v3 with the help of 5 with the help of size and a default value are going to print 9, 9, 9, 9, the element 9 5 times, because 5 is the 5 is the size of this vector. So I would like to encourage you people to at least try and run this particular program and see what is actually expected. So this was basically an example theoretical concept related to which we have seen in our previous previous lecture, in which we have created one empty vector when vector is created with the help of initializer list, and the third vector is created with the help of 2 parameters, one is size and another one is default value. If we look into initializer list more closely, So values of the list will be assigned sequentially. First value will be assigned to the first element of the vector, second value will be assigned to the second element, and so on and so forth. And initializer list, obviously we are going to enclose within the curly bracket. So looking into initializer list only, let us take one more example of using this initializer list, and instead of using that print v function, we are going to use here as this vector in the form of an iterator, so that all the values which we have assigned to them are printed one by one. So here you can see that example on the screen. So hash include bits standard C++ dot h. The significance of this particular inclusion statement I have already told you earlier. Then namespace standard is there, and within the main we have written the first executable statement within the main is vector int v is, and we have given an initializer list which is 11, 23, 45, 89. Now something which is to be worth noticing is given after this. So vector int v is equals to 11, 23, 45, 89 is the way through which we have used our initializer list, and we have given, or more specifically we can say we have created a vector v of 4 elements, and the values are given with the help of initializer list. Now if we want to iterate over all these elements, we can do this with the help of the keyword auto, or the so in order to use this, we will be using this inside the for loop. So we have for, then auto I, that means with the help of counter variable I need to iterate over the elements of v, and the syntax goes like for auto, for within the braces auto I colon v. So I is going to be operated as a counter variable on all the elements of v, and as we have written auto, that means it is going to use the properties of iterator, and it will iterate on the elements automatically. That means please notice here we have not used any kind of a stopping condition, that is v dot size less than this or something of that sort. Neither we have used any increment or decrement which is I plus plus or something of that sort. Both of the we can say both of the requirements are being eliminated, because iterators have the property to iterate over all the available elements, and when there are the elements which are all exhausted, no elements available, this iterator will kind of stop on its own. And because of this thing, there is no need to put any kind of condition based on the size. There is no need to put any we can say increment or decrement operator. So for within the braces auto I colon v, we are going to print I. So I is basically going to take one element of v at a time, and it will print and then finally return 0. So when you are going to kind of execute this program, when you are going to run this program, you are going to have a list of the elements which you have provided, which is 11, 23, 45 and 89. So this is the first way of initializing the vector with the help of initializer list, which is kind of a list of multiple values. Now the second way among those ways of among those 8 ways of initialization, the second is about one by one initialization. That means we are going to push the values of the vector one at a time, and in this method initially an empty vector is created, and then elements will be pushed into this container, or elements will be added to this vector one by one using a method which is known written as push underscore back method, and this method is mostly used to initialize the vector after declaration. So we are going to declare one particular vector, and then we will be pushing elements back. So, push back method is basically inserting the elements one at a time, and it is going to insert the element at the back of the at the last of the vector. And the syntax of this particular method is v dot push underscore back, within the bracket there is a val, where val is nothing but a value which we have to insert. V is the name of the vector in which we are going to insert, and push underscore back is nothing but the value of the name of the method. Now, in order to see how this push underscore back we are going to use is now every time in these examples we have established that why we are using this hash include and why we are using this namespace standard. This is all kind of set. So, I am just coming directly to the code inside the main function. We have declared one particular vector named as v, that of type integer, and the class name obviously is vector. So, we have declared one which is vector int v, and now we want to push elements one at a time. So, v dot push underscore back 11, then v dot push underscore back 23, then v dot push underscore back 45, and then v dot push underscore back 89, and again that same for loop which was given in the previous example for printing one at a time value of these elements of vector. So, all these elements which are 11, 23, 45, 89 are being kind of printed with the help of this for loop, which is using the iterator characteristics of this vector. So, here in the previous example we have supplied one initializer list now, but here we have initially we have created an empty vector and then we have pushed back some values. Third way of creating the vector is creation of vector with a single value. We can initialize all the elements of the vector with a single value. For this we need to create a vector of the specified size, for example, whatever number you need to have 5, 7, 9 whatever, and initialize all the elements to the same value using the constructor of the vector, which is going to take two parameters, one is size, another one is value, and the syntax goes like this, which says vector, then the type, then the name of the vector, and within this within the bracket we are going to pass two parameters to this particular constructor. So, basically whenever we are creating a vector, we are going to actually call the constructors which are available, which are actually overloaded constructor, we can say. So, one constructor is not going to take any parameters, another constructor is going to take a list, and the third one which I am talking about now is going to take two parameters, one is size which is the n here, and val is the initial value. Now, in order to use this, let us see within the main function we have used vector int v 5, 11. So, basically we are initializing all the elements of vector using a single value which is 11, and total number of elements in the vector will be 5, and we have used that for auto I colon v, that the same kind of for loop we have seen. This is having this will print 11, the element 11 5 times. So, we have seen three ways of creation of vectors using the initializer list, and then we have used this which is within a single value, and we have also seen the method in which we will kind of push back values one at a time. Now, coming to the fourth idea, how are we going to create a vector in more different ways. So, the fourth comes in this line is in the form of an array. We can also initialize a vector using a old static array which is already available with us, and we will be using a different vector constructor in order to use that array. And what will happen that all the elements of the array will be copied to the newly created vector. Now, what is the syntax? The syntax is vector type name of the vector, ARR, which is the name of the array, and ARR plus n. So, ARR is the array name and n is the size of the array. So, let us see how are we going to use this particular method. So, for that within the main we have declared an array in our conventional manner, which is integer ARR and 11, 23, 45, 89, and n is actually the size of ARR. So, within this element n or within this variable n, we have kept size of ARR, and this size of ARR is being given to us by the size of operator. And in place of size of ARR, we can also use size of ARR 0, both are the same thing. And then we have initialized the vector v, which we will be just creating by ARR. So, vector int v is equals to ARR and then ARR plus n, where n is nothing but the size. So, we are going to create, or a vector v is being created, and the 4 elements will be there, which are 11, 23, 45, 89, or whatever the values of that traditional array are there will be copied to the elements of vector, and using that for for loop we are going to print them in our in the manner in which we have done in our previous example. So, the two parameters which are to be passed, one is ARR, another one is ARR plus size. So, till this point we have seen 4 ways of initializing the vector. Now, one simple idea says, if a facility of creation of a vector is available by using the elements of already existing static array, this can also be done with the help of a vector. That means, we can also initialize a newly created vector from an already created vector, provided they are of same type. And we can also control the beginning and the end. That means, what elements, which all elements we need to include in our new vector, provided those elements should be continuous, because the syntax goes like vector type v2 v1 dot begin, that is a function, so it is coming with the parenthesis, comma v1 dot end, where v1 is nothing but the already existing vector. So, starting from this begin to end, in this example we are copying all the elements, we have not selected the elements, but we can also do that. So, here in order to use this method, first we will be creating a v1 vector, which is being created with the help of initializer list. Vector int v1 is equals to 11, 23, 45, 89, that we have already seen. Then we have vector int v2 starting from v1 dot begin, comma till v1 dot end, all the elements will be copied in v2, and if you are going to print v2, you are going to have all the elements 11, 23, 45 and 89. Moving further, we can also create vectors from any STL containers, because these vectors are basically, we can say, flexible containers that can also be initialized by any other already existing containers. Not only vectors, but it could be a set, it could be a multi-set or a map. Again, the condition is they should be of the same type, and the syntax goes like this, which is vector type v and then first and the last. First and the last are the iterators to the first element, and the last element which is not actually the last element, but the iterator to the first element and the element just after the last element in the range of STL container. So, this is an important point, that first is actually the iterator to the first element, and last is the iterator to the element just after the end element of that iterator. We can also use the standard fill function in order to initialize whole or part of a vector to the same value. Syntax of this fill function goes like this, which is fill, first, last and well. So, this is taking 3 parameters, where first and last are the iterators, as I have told you just now, to the first element and to the element just after the last element in the range of STL container, and well is the value to be initialized with. So, in order to see the usage of this example, let us see. So, here we have declared one vector which is of integer type, and the size of the vector is 5. Now, what do we want to do? We want to initialize this vector v with 11. So, starting from v dot begin to v dot end. So, that means all the elements 0, 1, 2, 3, 4. We are going to use this fill method, and the value which we are going to fill is 11. So, the syntax is fill v dot begin v dot end. So, starting from v dot begin till v dot end, this vector v will be filled with value 11, and if you want to print, you can use this for loop, and you will be having 11 element, the element 11 written 5 times. So, in this way we can use this standard fill method. So, till this point we have seen 7 methods of creation of this or initialization of vector. The last one is the iota function, which is also available as STD scope resolution operator iota function. It is from the numeric library, which allows us to initialize a vector with a consecutive values starting from the given value. What does that actually means? Let us try to understand. So, STD scope resolution operator iota, first, last and well, and I am sure you understand the value of first and last by this point. So, first refers to the iterator of the first element, last refers to the element or the iterator to the element just after the last one, and well refers to the starting value. Now, how this is going to be kind of used? So, here we have this function vector int v5, that is what we have created, a vector of 5 element, and we are going to use this iota function to initialize this vector v with 11. So, iota v dot begin to v dot end, all the elements are to be, or the elements are to be initialized with the value 11. So, in this lecture we started with a quick recap of what actually a vector is and why it is basically used, and then we have seen various ways of initializing this vector, initializing any vector. So, basically these are 8 ways which we have seen. And then in our upcoming lectures we will be moving towards the more basic operations which are to be done with the vector these kind of iterator, and here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed one. More on the vectors in our upcoming lectures. Till then, take care, see you, goodbye.